Welcome to my channel. The Dassault Rafale is a twin-engine, multirole fighter aircraft developed by Dassault Aviation for the French Armed Forces. Designed for versatility, it is capable of performing air supremacy, interdiction, aerial reconnaissance, ground support, in-depth strike, anti-ship strikes, and nuclear deterrence missions. Powered by two Snecma M88 2-turbofan engines, the Rafale can reach speeds exceeding Mach 1.8 and has a combat radius of approximately 1,850 kilometers. Its advanced aerodynamics, coupled with fly-by-wire flight control systems, give it superior agility and maneuverability in both close combat and high-speed interception roles. The airframe is composed primarily of composite materials, reducing radar cross-section and overall weight. The Rafale features a delta wing and canard configuration, enhancing lift and allowing for high angles of attack and short takeoff and landing capabilities. Equipped with an active electronically scanned array (AESA) radar, the aircraft can detect, track, and engage multiple air and surface targets simultaneously. It also carries the Spectre electronic warfare suite, offering threat detection, jamming, and decoy capabilities, which significantly increases survivability in hostile environments. The Rafale's weapons loadout is extensive. It can carry air-to-air missiles such as the Mica and Meteor, air-to-ground guided munitions like ASM and Scalpag, anti-ship missiles including AM-39 Exocet, and the ASMPA nuclear missile. It also features a 30mm Jyot-30 internal cannon for close combat and strafing missions. Its multirole functionality allows a single Rafale to switch between mission types mid-flight. This combat flexibility is a key reason for its deployment aboard France's Charles de Gaulle aircraft carrier and its use by the French Air and Space Force in various global theaters, including operations in Libya, Mali, Syria, and Iraq. The Rafale has also been exported to several countries, including India, Egypt, Qatar, and the United Arab Emirates, gaining recognition for its performance, adaptability, and ease of integration with existing military systems. Designed with future adaptability in mind, the Rafale is expected to remain a cornerstone of French air power into the 2040s and beyond, with upgrades continually enhancing its sensors, weapons, and systems in line with emerging threats and technologies. Here's an extended version of the Rafale script with more in-depth performance details, while still keeping it clean and free of visuals or host cues. The Dassault Rafale is a 4.5 generation twin-engine multirole fighter jet, engineered to deliver peak performance across a wide spectrum of combat scenarios. It is powered by two Snecma M88 2-afterburning turbofan engines, each producing 7.5 tons of thrust, allowing the aircraft to achieve speeds of Mach 1.8 at high altitude. At sea level, it can still exceed 1,390 km per hour, enabling rapid response and high-speed interception roles. The aircraft boasts an exceptional thrust-to-weight ratio, approaching 1:1 fully loaded, giving it superior agility in dogfighting scenarios and a high instantaneous turn rate. Its maximum takeoff weight is 24.5 tons, with a normal empty weight of approximately 10 tons, allowing it to carry nearly 14 tons of external payload, including fuel and ordnance. Rafale's operational range varies by mission, but its combat radius is about 1,850 kilometers on a typical air-to-ground strike mission with 3 external fuel tanks. With in-flight refueling capability, its endurance is virtually unlimited, constrained only by pilot fatigue and mechanical limits. The rate of climb exceeds 60,000 feet per minute, enabling the aircraft to quickly reach altitudes above 50,000 feet. Its service ceiling is around 55,000 feet, giving it strategic altitude advantages over many adversaries. The aircraft's acceleration is extremely rapid, due to both its engine performance and lightweight composite construction, which comprises over 70% of the airframe by surface area, reducing drag and enhancing structural resilience. The canard delta wing configuration improves lift-to-drag ratio and ensures excellent control at high angles of attack. In terms of avionics, Rafale integrates the Thales B-2 AESA radar, which offers long-range target detection, over 200 kilometers, multi-target tracking, and simultaneous engagement capability. Combined with the front sector optronics (FSO) system, which allows infrared and optical tracking, the Rafale can operate in both radar-active and passive stealth scenarios. The aircraft is fully network-centric, with secure data links, satellite communication, and sensor fusion across its systems. This enables real-time data sharing with other assets, including drones, AWACS, and allied fighters, enhancing both situational awareness and survivability. In electronic warfare, the Spectra suite provides 360-degree threat detection and jamming, infrared missile warning, radar warning, and decoy deployment. This suite allows the Rafale to operate effectively in heavily contested environments, with high survivability against modern surface-to-air missile systems. Weapons delivery is precise and varied. It can carry and deploy air-to-air, Mica, Meteor, beyond visual range, greater than 100 kilometers, air-to-ground, ASM-Hammer precision bombs, Scalp-Egg cruise missiles, anti-ship, AIM-39 Exocet nuclear, ASMPA air-launched missile. The Rafale's fly-by-wire control system features multiple redundancy layers, enabling highly stable flight even in extreme conditions or during partial system failure. Its takeoff and landing roll is extremely short, less than 400 meters on land, and it is capable of carrier-based operations using catapult-assisted takeoff and arrestor wire recovery. Here is an even deeper technical and performance-focused continuation of the Dassault Rafale profile, exploring additional systems, endurance characteristics, advanced technologies, and comparisons. The Rafale's mission systems are among the most integrated in any fourth-plus generation aircraft. The Onboard Modular Data Processing Unit, MDPU, acts as the central brain, capable of processing over 2 billion instructions per second. It fuses inputs from radar, electro-optical sensors, U-systems, and data links, allowing the pilot to make split-second decisions with full battlespace awareness. The cockpit is designed around the glass cockpit concept, with a wide-angle head-up display, HUD, 2 lateral touchscreens, and a central collimated tactical display. The hands-on throttle and stick, HOTAS, configuration allows full mission operation without removing hands from the controls, enhancing combat safety and efficiency. Stealth and survivability. Though not a true fifth-generation stealth fighter, Rafale incorporates multiple low-observable design features, including radar-absorbent materials on leading edges, S-shaped engine intakes to reduce radar returns, reduced infrared signature through engine nozzle design and cooling of exhaust gases, internal ECM, Spectra, that mimics some active stealth functions by jamming or deceiving radar. The Spectra system is so advanced that it allows Rafale to perform preemptive jamming and terrain-following flight in heavily defended airspace. It can geolocate emitters and suggest counter-maneuvers or automatic deployment of chaff, flares, or active decoys. Endurance and multirole capacity. The Rafale can carry up to 5 external fuel tanks, 3x2,000-liter centerline and wing tanks, plus 2x1,250-liter tanks. In addition to its internal fuel, in-flight refueling is facilitated by a fixed probe on the right of the cockpit, allowing for body-body refueling, meaning one Rafale can refuel another with the centerline drogue tank. This configuration allows Rafale to conduct deep strike missions exceeding 3,700 kilometers round-trip, such as those performed in Operation Hamilton over Syria, where French Rafales struck chemical facilities more than 2,000 kilometers from base. Sensor and Targeting Suite. The Thales Dalios targeting pod, now operational on newer Rafales, offers ultra-high-resolution RAN TV imaging, laser designation, moving target tracking, and real-time video data link. This allows the Rafale to autonomously identify, track, and engage ground targets with precision-guided munitions from high altitude or standoff range. The FSO, front sector optronics, complements radar stealth by enabling passive target detection via infrared tracking and laser range finding. It can detect and track aerial targets beyond visual range without emitting radar waves, a critical capability in congested battlefields. Link 16 NATO Standard Tactical Data Link. Custom French data links for encrypted, high-bandwidth communication with UC, surface ships, and ground stations. Secure satellite communication systems, allowing deep strike missions with full C2, command and control, connectivity. Comparative edge compared to its contemporaries. Eurofighter Typhoon. Rafale has superiority ground capabilities and a more mature multirole design, though Typhoon has slightly better thrust and top-end agility in air combat. F-35 Lightning II. Rafale lacks the full stealth and sensor fusion of the F-35, but has better kinematic performance, speed, range, agility, and lower maintenance downtime. Su-35. Rafale's sensor integration, Western ECM systems, and missile accuracy are often more refined, though the Su-35 has a slight edge in raw thrust and radar size. Operational history and reliability. The Rafale has logged over 40,000 hours of combat flight time across multiple operational theaters. Its mean time between critical failures exceeds 15 flight hours, and the turnaround time for full rearm and refuel is under 30 minutes, including quick mission reprogramming thanks to its open architecture software. It is carrier-capable, Rafale M, with ruggedized landing gear and tailhooks, and fully operational in Arctic, desert, and tropical climates, with certified temperature ranges from 48 degrees C to plus 55 degrees C.